Hi everyone, welcome back to my channel. In today's video, we're going to explore a special type of force system known as a couple, a concept with unique properties and important applications in engineering mechanics. But what exactly makes them special in engineering mechanics? Let's find out. A couple is essentially a moment created by two forces that are equal in magnitude, opposite in direction, parallel to each other, and lastly, non-collinear. That is, they are not acting in the same line. Now consider the action of two equal and opposite forces F that are a distance d apart. The resultant of this system is zero in both horizontal and vertical directions. Their only effect is to create a tendency to rotate an object, which we call a moment or torque. Unlike other force systems that can also cause translations, a couple doesn't push an object in any direction. It purely tends to twist or turn it. The direction of a couple can either be clockwise or counterclockwise. By convention in mechanics, a clockwise couple is usually considered negative, while a counterclockwise couple is taken as positive. This sign convention helps us maintain consistency when solving problems involving moments. But remember, the positive and negative sign doesn't change the physical effect of a couple. It only provides a systematic way to represent its rotational tendency. We can observe couples in many everyday situations. For example, when you turn a steering wheel, your left hand pushes one way while your right hand pushes the other. Together, they form a couple that rotates the steering wheel. These real life examples show us how a couple works in practice. But how do you actually measure the strength of a couple in mechanics? The magnitude of a couple, often denotes by capital letter M, is equal to the sum of the moments of the couple's forces about any axis that is perpendicular to their plane. Let's take an example. Imagine a point A, which is at distance A and B from our two forces. The magnitude of the couple is simply the sum of the moments produced by these two forces. Let's assume counterclockwise moments are positive. So the moment M will be equal to F times A minus F times B. Now notice that B can be expressed as A minus D, where D is the perpendicular distance between the forces. Substituting this into our equation, M will be equal to F times A minus F times A minus D. Expanding the equation, the terms Fa will cancel out, leaving us M is equals to F times D. To put things into context, you may wonder why the terms A and B have completely disappeared from the equation. This happens because the moment of a couple is independent from the reference point we choose. That's the unique thing about couples. They act as free vectors. No matter where you measure from, the moment will always depend only on the force and the perpendicular distance between them. Let's take an example to see how couples work. We have a 6-meter beam with ends A on the left and B on the right. A couple acts on a beam. Two equal and opposite forces of 5 kilonewtons placed 1 meter apart. The left force is 3.5 meters away from point A. The formula for the moment of a couple is simply M is equals to F times D. So here, M will be equal to 5 kilonewtons times 1 meter, which is equal to 5 kilonewton meters counterclockwise. Now let's take the moment about point A. The total moment MA will be the sum of the moments of these two forces about A. The left force at 3.5 meters tends to rotate the beam clockwise about A, so it is negative. The right force at 4.5 meters rotates counterclockwise about A, so it will be positive. So the total moment MA will be equal to 5 kilonewton meters counterclockwise. Now let's take from point B. From B, the left force is 2.5 meters away and the right force is 1.5 meters away. The left force rotates counterclockwise about B, so it is positive, while the right force rotates clockwise about B, so it will be negative. So the total moment mb will be equal to 5 kilonewton meters counterclockwise. So what do we see? Whether we take the moment about A, about B, or even any other point, the answer will always be the same. That's the special property of a couple. Its moment is constant everywhere. In this case, it is always 5 kilonewton meters counterclockwise. So to summarize, a couple is formed by two equal, opposite, parallel, and non-collinear forces. Its resultant is only moment, and the magnitude of the couple is simply the product of one of the forces and the perpendicular distance between them. Couples may seem like a simple idea, but they form the foundation of how we understand rotational effects in mechanics. And that's it for now. Thank you for watching. Don't forget to like and subscribe to my channel, and I'll see you in the next one.